So today we're going to discuss the first section here in Chapter 9, which involves adding and subtracting polynomials. Okay, and so given the nature of the section, obviously the goal by the end of this video and by the end of class tomorrow or the next time I see you is that you should be able to add and subtract polynomials. Okay, which you may or may not already be familiar with. So the first thing is just a few different things that we want to become familiar with. There's a lot of vocabulary here in this first section because as we go through the rest of this chapter, you need to understand, if I say a polynomial or the third term or things of that nature, what I am exactly talking about. Okay, and so again, as I said, this first section deals with a lot of vocabulary. There won't be as much as we move forward. Okay, so what is a monomial? A monomial is very simply a number, a variable, or the product of a number and one or more variables with whole number exponents. Okay, so an example of a monomial is very simply something like, I don't know, my apologies. See if I can get the board tools up here. All right. A monomial would be something like 2x squared y to the sixth. Okay, again, your exponents are whole numbers, therefore that is a monomial. Okay, another example of a monomial would very simply be something like, I don't know, negative 1.2 n to the seventh power. Okay, and so when we talk about monomials, that's all we're talking about is it's a product of a number and one or more variables with whole number exponents. Just something that I want you to be familiar with. Okay, the degree of a monomial is the sum of the exponents of the variables. Okay, so for example, if I give you the monomial, let's just say, I don't know, let's write down 2/3 x to the third y to the fifth. Okay, well again, the degree of a monomial is the sum of the exponents of the variables. Okay, well this exponent here is 3, that exponent is 5, therefore degree is 8. The degree of that monomial would be 8. Okay, it's very simply the sum of the exponents of the variables. Okay, again, nothing too crazy there, but just some vocabulary to be familiar with. Alright, so here's just a quick little rundown, and I'm going to go through these pretty quickly because I don't want to take up too much time when we really got to get into some nuts and bolts here of adding and subtracting polynomials. So, first we want to determine if it's a monomial or not. And so remember, we go back and we say, okay, monomial is a number, a variable, or the product of a number and one or more variables. So, is this 17 a monomial? Yes, it is. What's the degree? Well, there's no exponents, and if there's no exponents, that means the degree is 0. Okay? Monomial? Yes, it's a product of 1/3 x and y, and the degree, well, the exponent here is 3, the hidden exponent there is 1, 3 plus 1 is 4. Okay? Monomial? No. Why? It's the sum, not product. Okay? Remember, monomial is the product, not the sum. Okay. Questions on this table, just bring them to class tomorrow. You have the rest of them that you can kind of work through on your own, but I think that's pretty straightforward, and hopefully you're good to go there now. Okay. So what's a polynomial then? Okay. Poly means many. I should have pointed this out. Mono, the prefix mono means one. The prefix poly means many. So a polynomial is a monomial or a sum of monomials, each called a term of the polynomial. What? There's a lot of onomials in there. Okay, I don't want to get all caught up in all this verbiage. Okay, but essentially a polynomial is something as simple as this: 2x squared plus 3x minus 4. Okay, each term, right? There's 3 different terms. There's 1, there's 2, there's 3. Okay. And each of those terms is a monomial, right? The product of a number and variables with whole number exponents. So 3x is also a monomial, and 4 by itself is a monomial. So you get the idea. That's what a polynomial is. You're familiar with them, you've worked with them, but now we're just kind of giving a definition to it, and maybe it's just review. Hopefully it's just review. Okay? And the degree of a polynomial is the greatest degree of the terms in the polynomial. Okay, so for example, if I go through and I write out the polynomial, I don't know, let's just say 2x squared plus x squared minus 5x plus 2, the first thing we're going to want to do is combine like terms here. Okay? And so when I combine those like terms, I end up with 3x squared minus 5x plus 2. Okay, and so now when it asks me what is the degree of the polynomial, the greatest degree here is 2. Okay, so the degree of this polynomial would very simply be 2. Okay? All right, moving forward. The leading coefficient is very simply the coefficient of the first term in a polynomial that is written with the exponents of variable decreasing from left to right. Okay, so in other words, if I want to identify the leading coefficient, if I'm given something like this, I'll make it pretty simple here. 3y plus 4y squared minus 12. Okay, if I'm given that polynomial, in order for me to identify the leading coefficient, I first have to rewrite this so that my degrees are decreasing from left to right. Okay, so you'll notice this degree here is bigger than the degree here, which is just 1. And so I have to rearrange this. I have to rewrite this as 4y squared plus 3y minus 12. Okay, and so now the leading coefficient is just this guy out here in front of the y squared. So my leading coefficient here is just 4. All right, and that's it. So again, that's going to be useful when we talk about, if I'm saying, okay, what's your leading coefficient, or what's the coefficient of the y, things of that nature. You understand what coefficient is now, hopefully. Okay, binomial is very simply a polynomial with 2 terms. A polynomial with 2 terms. Example: x squared plus 4. That's a binomial. A trinomial, tri means 3, a polynomial with 3 terms. X squared plus 4x plus 4. 1, 2, 3 different terms, therefore it's a trinomial. We won't probably refer to them as binomials and trinomials a ton, but still useful for you to know. So if a problem says multiply out the binomial, you're not sitting there wondering what the heck is going on. Okay? A constant term is very simply a term without a variable, okay, and that the degree of that is always 0. All right, so if I were to give you the expression x squared minus 4x plus 7, the constant term here is just this 7. There's no variable with it, so it's 7, and the degree of that 7 is just 0. All right, I think that's pretty straightforward there, okay? So in this first example, it says write 10x squared minus x cubed plus 3 so that the exponents decrease from left to right. Very simple idea here. Okay, so I have to rearrange. I think we all agree that the 3 is bigger than the 2, so I got to drag this whole term out in front, the whole term. So out in front I have negative x cubed. This is positive, so it's plus 10x squared plus 3. That's all they wanted me to do, is rewrite it so that your degrees or your exponent decrease from left to right. Okay. This next one here says identify the degree, the leading coefficient, and the constant of the polynomial. All right, so the way I would do this problem is when it says write that so that the exponents decrease from left to right, I'm going to find the biggest exponent, so that 5 is my biggest exponent, so I know that that term is going to be my first term. So I have 2xy to the 5th, and then I'm just going to decrease my y's, okay? The next biggest y exponent I have is that 3, so I have minus 3x to the 4th, y to the 3rd. The next biggest y I have is this, it's just 1, so I have minus 5x squared y, and then I have the minus 17 all the way at the end. Okay, and it says identify the degree. Okay, so the degree is the highest exponent of the terms. So what I want to do is I have to take this 5 and the 1 here, add them. So the degree there is 6. The degree here is 4 plus 3, which is 7. Degree here is 2 plus 1, which is 3. Well, the biggest one is 7. Therefore, the degree here is going to be 7. So the degree is 7. The leading coefficient is just the guy out in front of my leading term, so it's just 2. And the constant is just the number by itself. The constant is the negative 17. Okay, so again, that one was a little bit tricky in terms of writing it in decreasing order. I don't know that I'll ask one that's confusing like that on the quiz or test, but nonetheless, you should be able to identify the degree, leading coefficient, and the constant of a polynomial. All right, so this is just a quick table similar to what we did for the monomial, identifying if it's a polynomial or not. Okay, so the first thing we're going to do is a polynomial. Okay, well, recall what a polynomial is. A polynomial is very simply a monomial or the sum of monomials. Okay, more specifically, a polynomial is, well, that's all it is. Okay, a monomial or a sum of monomials. So is 9 a monomial? Absolutely, that's a polynomial. Leading term? Well, the leading term, there's only one term. It's just 9. Leading coefficient is just 9. The degree is 0. Is it a monomial, binomial, trinomial, or none? It's monomial. There's only one term. Okay? Polynomial, yes. Leading term, the 2x squared is the leading term. The leading coefficient is just the guy way out in front. It's just a 2. The degree of the polynomial is 2, and there's 3 terms here, so it's a trinomial. Okay, finally, we're getting into actually what we want to talk about today, and that's adding and subtracting polynomials. Okay, so I want to find the sum. The biggest thing for you to understand when adding and subtracting polynomials is you can only combine terms with the same degree. Okay, so for example, I have 4x to the third. I have a 1x to the third over here. I can combine those now. 4x to the third plus a positive x to the third, that's just 5x to the third. What I would do is I'd actually rearrange this to get all my degrees close. So I'd have 4x to the third plus x to the third. So I've taken care of those two. All right, and then I look at here, I have negative 3x squared, and I have positive 5x squared. So I have negative 3x squared, positive 5x squared. And then finally, I have positive x. There's nothing else, so it's just plus x. And lastly, I have the negative 3, and that guy just goes at the end. And now I combine all my like terms. These have the same degree. 4x to the thirds plus 1x to the third leaves me with 5x to the thirds. Negative 3x squared plus 5x squared is 2x squared. And then the x and the minus 3 are just going to stay by themselves there at the end. Okay, so that would be the sum of those two polynomials. All right, find the difference. So now we're just subtracting. A little bit different, probably a little bit trickier, because I have a 4x squared minus negative 5x squared. Okay? Well, remember, subtracting a negative is the same thing as plus plus. If it helps you, turn this into an addition problem. Distribute this negative. So I distribute this guy to every single term inside, and so what happens is it becomes plus 5x minus 4x plus 1. So I have 4x squared plus 5x squared. That's 9x squared. Okay, I have negative 4x, and that's all by itself, so I have negative 4x. And I have a positive 6, and I have a positive 1. Positive 6 and positive 1 makes positive 7. All right, again, pretty straightforward once you kind of get the hang of combining things with the same degree. And then here's one last story problem to finish up with. It says during the years of 1999 to 2005, the number of hours an individual person watched broadcast television and cable and satellite television can be modeled by those two expressions. Okay, where T is the number of years since 1999. About how many hours did people watch television in 2002? Well, again, you either watched broadcast or you watched cable and satellite. So the total number of people who watched television in 2002 is very simply B plus C. So when I add these two things together, I'm going to do it kind of combine it all in one step. So I have 2.8 T squared, negative 5 T squared. So 2.8 plus negative 5 leaves me with negative 2.2 T squared. And then I have negative 35t, positive 82. When I add those two things, I have negative 35 plus 80. I get 100. Oh, that's wrong. I apologize. I have negative 35 plus 80, which is 45t, positive 45t. And finally, I have positive 879, positive 712. So I have 879 plus 712. So this expression here, plus 1591. This expression is my model. That represents the number of people or how many hours people watch TV.